In this video, I would be going through 1.3, which would be arithmetic growth and decay. Um, Arithmetic sequences, we've talked about last lesson, is about, if you have a sequence that that adds the same amount every single term, that's an arithmetic sequence. We can sometimes use those to solve real life problems, and this will be the arithmetic growth and decay. Growth for things that continue growing at the same rate every single year, and decay if the number decreases the same amount every single year. And so let's have a look at the first example. It says here there's a forest program in which there are some trees that grow an average of 12 to 18 inches per year. And so the situation is a evergreen tree over here is 6 inches high. That's the starting point, okay? An evergreen tree 6 inches high was planted in June 2000. And it has a growth rate of 15 inches per year. That means that every single year it grows 15 inches. Now, there are, at the first part over here in this example, they talk about two different students and how they go about solving this question in a different way. They're similar but slightly different. So we have Joel, the first student, beginning his sequence with 6, 21, 36. And so we can have a look over here that in Joel's sequence, term 1 is 6, right? So 6 is term 1, and then we have 21 as term 2, and then we have 36 as term 3. And then there's another student, Jenna, which we'll talk about later, that starts the arithmetic sequence beginning with 21. And we'll talk about that later. So we want to use the formula to determine to answer some problems. So let's first do part B, which is to determine the formula for the general term of Joel's arithmetic sequence. So Tn over here is equal to 6 plus n minus 1, and the common difference is 15. And so let's go ahead and expand the bracket. 15 goes into both of these terms. So that's 6 plus 15 and minus 15. And then 6 subtract 15. I'm just going to use my calculator to be sure because of negative numbers. 6 minus 15 will give me negative 9. So Tn would be negative 9 plus 15n. Now let's go ahead and uh, use this to determine part E. If the tree continues to grow at the same rate, in which year will it reach a height of 28 feet? So first of all, it grows at 15 inches per year, and it started off 6 inches high. So we want to work out what 28 feet is in inches. Okay, so first of all, 28 feet, let's convert that to inches by multiplying 12. So 28 times 12 will give us 336 inches. So we want to work out, which term we would get 336. So Tn, we're going to substitute 336 into Tn. So Tn is equal to negative 9 plus 15n, and we're going to put 336 in. So 336 is equal to negative 9 plus 15n. And then let's do a little bit of algebra. 336 plus 9, and then we want to divide it by 15, and we would get n is equal to 23. Okay, just because we figured out what n is, that is the nth term, it doesn't mean that we know which year it is. Now let's go back to the beginning. At the beginning, in the year 2000, the tree was 6 inches high. And so, with the 23rd term, which year is that? Does that belong to year 2023, 2022, 2024? We'll have to figure that out carefully. And so, usually what I would do is I would write down in the year 2000, the tree was 6 inches, right? It was 6 inches. And for the Joel's way of working, that is term 1. Okay, that is term 1. This is going to be T1. And I'm going to write a few just to make sure I sort of understand, what's going on. The next year in 2001, the tree would be 21 inches, and that would be term 2. And in year 2002, that would be term 3. It will be 28 inches, sorry, not 28, it will be 36 inches. And so just from looking at this, I can sort of see a pattern. For term 1, it is year 2000. For term 2, it's 2001. Term 3 would be 2002. So every single term, the year number would be one less than that. And so if we're looking for the 23rd term, if we're going to go all the way to T23, this should be 1 year less than 23. So that's going to be 2022, and that will be 336 inches. Okay, so this is Joel's way of solving it. Okay, so we've calculated that it is 2022. Let's now have a look at Jenna's way of solving it. So Jenna does it a little bit different. She starts off with 21 as her first term, and then 36, and then 51. So this is now her T1, this is her T2, and 51 is her T3, meaning that her Tn formula is going to be 21 plus n minus 1 times 15. And when we multiply out the brackets, that's going to be 21 plus 15n minus 15, which is going to be 6 plus 15n. It is slightly different from Joel's formula. Okay, so if we compare Joel's formula, that's the one in blue, and if we look at Jenna's formula, that's the one in also blue. Why are the formulas different? So the reason that they're different is that Jenna uses 1 year later as the first term, whereas Joel uses the beginning, the starting year as term 1. So Joel uses starting year, starting height as T1, whereas Jenna uses 1 year later as term 1. Meaning, if we were to calculate the same question, what height will it reach 28 feet, we'll have Tn equals to 6 plus 15n, and then 336 is equal to 6 plus 15n. We're going to do a little bit of algebra to solve it. So 336, subtract 6, and then divide it by 15, we would get n equals to 22. Now let's have a look at why Jenna does it this way. At the year 2000, it was 6 inches. So 1 year later, it's going to be a term 1. That's Jenna's term 1. Okay, so in year 2001, that's 1 year later, that's 21 inches. That's going to be Jenna's term 1. And so you see how in Jenna's formula, the term number and the year number is the same. So she thinks that this is easier for her to do it, which means that she can easily say by the time it is T22, that's going to be the year 2022, which is 336 inches. Now, there is no which way is better. You have to determine for yourself which way you prefer. Now, I personally prefer to use the left side because I just like to stick with Tn equals to n minus 1d. First term is always the starting term. That's just my personal preference. But if you prefer to use 1 year later as T1, then please go ahead and do that as long as you are consistent with your work and as long as you understand what you're doing. Now, for me, the most important thing is this part where you have to actually, sort of draw out a timeline for yourself to determine which term is which year. Okay, this is important. Okay, if you do all the calculations correct, but then in the end, you got the year number wrong, that is a bit of a shame because you've done all the work, you just forgot to align the year with the term numbers. Okay, so it's very important that you remember or you check which year corresponds to which term number. Okay, let's go through a second example. Oh my goodness, the video is already 9 minutes long. So I'll try to make this a little bit shorter. I'll go through this a little bit quicker. The second one is about a printing press. Okay, so it starts off with a purchase value, and then every single year it's going to depreciate in value by the same fixed amount. Okay, so 5 years after it was bought, the printing press had a value of 311. And so if we have a look at it, it had a scrap value of $2,900 in the year 2010. Now, year number is a little bit, hard to determine. Now, let's just quickly draw a timeline. In 1992, it had a purchase a price of something, which this is going to be T1 for me. Now, I just prefer to use T1 as the first term. If you prefer to use 1 year later as T1, go ahead and do that. That's your personal preference. And so in 1993, that's going to be T2. And then in 1994, that's going to be T3, and so on. And now I can notice that every single year number is going to be one bigger than the term number. Okay, so it says here 5 years after it was bought. So from 1992, 1 year later, 2 years later, 3 years later, 4 years later, 5 years later, that's 1997. This is T4, T5, T6. Okay, it doesn't hurt to draw a few more lines over here, or to look at your timeline a little bit better. It had a value of 311,000 and $311,000. Okay, so 311000. That is T6. It says it had a scrap value of $2,900 in the year 2010. So in the year 2010, we're going to go all the way to 2010. Now, remember, every single year number is one greater than the term number. So at 2010, it's going to be one greater than the term number, which means it's going to end with 9. Now, I know it's not going to be T9 because it's a lot longer. 29 also is not correct. That's too long of a time because it doesn't go up to 30 years. So this one is going to be T19. That's almost 20 years later. So from 1992 to 2010, it's almost 20 years later, which is T19. This one has a scrap value of $2,900. Now, this sort of example is very similar to the arithmetic means one, where you're given one term in the middle and another term later, and you have to work out what the common difference is, and then you can work out what the first term is. Okay, so remember, for this type of questions, the common difference is going to be TQ minus TP divided by Q minus P. Okay, where we have the later term minus the earlier term divided by the term numbers. Okay, 19 minus 6 in this case. Okay, so we want to work out D. That's going to be TQ, which is $2,900. That's the final term. Subtract the earlier term, which is $311,000. All of it divided by T19, which is 19, minus P, which is 6. So put this all into your calculators and work out that common difference. 2,900 subtract 311,000. All of that divided by 19 minus 6 in a bracket. And you would get a common difference of negative 23,700, which means that every single year the printer depreciates by $23,700. Okay, so let's have a look now. We want to determine the purchase price. We want to work out what T1 is, the year that it was bought. But so to do that, we're gonna we can say that the general term Tn is going to be the first term A plus n minus 1, and the common difference is negative 23,700. So let's go ahead and multiply out the bracket. So we'll have Tn is A plus, sorry, not plus anymore because that's negative 23,000. So minus 23,700 n, minus times minus will be plus 23,700. So this will be my general term, but I don't know what A is, and that's what we're trying to find in part B. So Tn, we don't know Tn, but we do know a term. Okay, I can either choose to use term 6 or I can choose to use term 19. I'll just choose one of them. It's okay. I'm going to choose term 6 just for now. So I know that at T6, that's $311,000. So 311000, that's T6, okay, is equal to A minus $23,700 N, and I know that N is 6, okay, because it's T6, right? T6. So we're going to put 6 in here, and then plus 23700, and we want to work out what A is, and so we're gonna put everything into our calculator. We're gonna multiply this out. 23700 times 6. Okay, that's subtract, and so we need to add it over to the other side. So 311000 plus whatever we got there, and then now we have to subtract 23,700, so minus 23,700, and the purchasing price was $429,500. That is going to be A. Okay, so that's how we use, these arithmetic sequence to determine what the purchasing price is. Okay, so I will leave this video as here. If you have any further questions, feel free to ask me.